question 15, 3 unbiased dice are rolled. Calculate the probability they will all land on a 5. So I need the probability of a 5 and another 5 and another 5. So the probability to get a 5 on the first one is 1 over 6. Probability to get a 5 on the second one is also 1 over 6. Probability to get a 5 on the third one is also 1 over 6, which ends up as 1 over 216. Part B. 4 dice are now rolled. Calculate the probability that at least 3 of them will land on a 5. So this is a bit more complicated. For a start, there's 4 dice, and also I'm looking at 3 of them landing on a 5. So what I want to happen is probability of a 5 and 5 and 5 and not a 5. So if I just consider one scenario in which that can happen, I get a 6th and another 6 and another 6th. And on the last one, I don't get that 5, so it's 5/6. Now, that's one scenario that can happen. But in that scenario, I'm assuming the first 3 land on a 5 and not the last one. Now, this not 5 could come in any of the 4 slots. So effectively, I've got 4 lots of that scenario, because this 5 over 6 could happen in any of the places. If I multiply all these together and then times it by 4, I get that is 20 over 1296. Now, we haven't quite got the answer because there is one other scenario we need to consider. This says at least 3 of the dice land on a 5, which means there is a final scenario I need to consider, which is where all 4 actually land on a 5. So that's 1 over 6 times 1 over 6 times 1 over 6 times 1 over 6. That comes to 1 over 1296. So then I've got to add these two together, which gives me a combined probability of it happening of 21 over 1296.